Hello everyone. As I wrote in an email, so even though I don't have any symptoms, though fully vaccinated, to maximize our safety call, I decided to record this video as a asynchronous lecture today. So I will cover the confidence interval and what we scheduled for this morning today. But yeah, I will contact you as soon as possible once I get any test result or what other things. All right. Last week, we stopped at the confidence interval because of the lack of time and too hard to go to the faster progress. But in short, the confidence interval means that based on our sample statistic, so using sample mean, sample standard deviation, and sample number of cases, we are estimating, so we are checking and estimating the possible range of the numbers. So from some number to other number, we are calculating some level of the confidence interval. So it means that within some range of the number, we expect the population mean would be between those two numbers. So as I mentioned many times, the population parameters are ideal because these are the exact number of the older people in the population or some society. And after having those number, population mean and standard deviation, that would be very perfect number. But that's not realistic, so we are using the sample number. So by using the sample statistic, we are calculating some specific range, and then we argue that within this range, so we have the 95% confidence that the population mean would be inside of this range. So I will show you more example. So again, in definition, the confidence interval means the possible range of the number that captures the population mean based on sample characteristics, sample statistics. So when we have the population, when it's almost impossible, and we can expect some possible range of the number that captures the population mean. So that is calculated as confidence interval equals sample mean plus minus T critical, we could use based on the T table, you may remember, and sampling error as calculated as sample standard deviation divided by square root number of cases. So by using those numbers in the program, an Excel program or whatever you can use the calculation, or we can calculate this as specific range because the one number is sample mean minus T critical multiplied by sampling error and M plus. So mean plus T critical multiplied by the sampling error. So we would have the two numbers as a range of the confidence interval. So the first example is population mean. Let's suppose that we don't know the number. The sample mean is 85, standard deviation is 25. Sample standard deviation is 25. And number of cases is 20. So based on number of cases of the sample, we can use degrees of freedom. So you might remember degrees of freedom is n minus 1. So 20 minus 1 is 19 in this table. So the row is degrees of freedom, and we are using 95% confidence interval. So it means that we are using 0.95 or 0.05 as alpha level because that means or that indicates 95% as a condition. So by checking the numbers here, we can find 2.093 as T critical, this part. Then sampling error is calculated as standard deviation divided by square root number of cases. So that is 25 divided by square root 2. So that is around 5.59. So usually you can round off or round down or round up based on two decimal places or 100th decimal place. So based on those numbers, we have confidence interval. The 95% confidence interval is 85 plus minus 2.093. So again, 85 is the sample mean here, right? 85 plus minus 2.093 as t-critical we could find based on degrees of freedom, and 5.59, which is the sampling error. Then after this calculation, by using your calculator or Excel program, we can calculate the confidence interval is 73.3 through 96.7. So now we can interpret that we have a 95% confidence that the population mean, or the number of complicated cities, whatever, and based on the variable measure or our hypothesis, we have the confidence interval between 73.3 and 96.7. So anyway, in 95% confidence, the population mean would be between this range. So we have about around 23 points in between those numbers as a possible hypothetical range of the range of the number captures the population mean within that range. Another example is using some specific or different number. So population mean is 80, so in our expectation, and the sample mean is 115 this time. And we have the bigger number of the sample size as 101. So degrees of freedom is n-1 again. So degrees of freedom can be found in this example is 101 minus 1. So 195% confidence interval. So intersection is 100 and 0.05 as 1.984. So 1.984 is the t-critical, and the SEM is calculated as 25 divided by square root 10. So it's around 2.49, or I think it's approximately 2.50. So the rounding of error is not a problem. So m equals, the sample mean is 150 plus minus 1.984, which is a t-critical, and 2.49 in this calculation is, so this range, so 145 through 154.9, we can calculate. So we can calculate the range of the confidence interval. So based on this number, we can find some special range which captures the population mean within that range. So this is the example. So these are the possible examples again, and based on this example, so the population mean is 15, and the sample mean is 17, and the standard deviation of sample is 5, and number of cases is 10. So the first question would be, do you think the sample mean and the population mean are statistically significantly different from each other? So you would perceive that as we have the population mean and the sample mean and sample standard deviation and number of cases, probably the z-score is not the case because we don't know about the standard deviation of the population, because standard deviation of the population is denoted as sigma. So now we just have the sample standard deviation. So we are using one sample t-test comparing population mean and the sample mean. So by using that criteria, we can calculate this one. And what is 95% confidence interval? So as we just covered in the example, or we could use the equation as sample mean plus minus t-critical multiply the sampling error. So that will be the possible calculation. And let me show you how to calculate that. So actually this is the example. Yeah, this is the answer here. So in this example, so the step number 1, so every time whenever you do the hypothesis testing, step number 1 is just setting up hypothesis. So H0, which means no hypothesis, they are very cynical again. So there is no difference between population mean and sample mean. So there is a null hypothesis. Alternative hypothesis is anyway arguing that there is difference. So there is difference between population mean and sample mean will be the first step. And again, the step number 2 is setting up the critical area. So we are not assuming that we have the population parameter and also population sample distribution, population distribution. We are using the sample distribution, meaning that we need to find the T critical every time based on number of cases. So by using the T table, again 0.05 as alpha level, and 10 minus 1 is the degrees of freedom because n is 10 in this example. So n minus 1 is 9. Again, so 2.262 is the T critical. So T critical is 2.266 because there are two numbers. So positive 2.262 and negative 2.262 is the T critical here. But anyway, we are here and we are just using those two numbers when we draw on the T critical area. So in this curve, negative 2.262 and positive 2.262 is the T critical we can use. So the T is the sample mean minus, so sample mean is 17 here, and population mean is 15. So T1, let me show you the equation here. Alright, so n minus u divided by sample standard deviation divided by square root number of cases. So 17 minus 15, which are sample mean minus population mean, divided by sampling error, so which is 5 divided by square root 10, which is approximately 1.58114. So after this calculation, that is divided by 2 divided by 1.58144, which is 1.26. So now we can find that this number is between those two numbers, because there is 2.27. Let me see. Let me use the Paint program. So I want to have, okay. Now we found that this is 0 and this is negative 2.262 and this is positive 2.262, right? And these shaded parts of the areas are T critical. So when we find some T value inside of those shaded area, these are some clue that we can reject the null hypothesis. So after rejecting the null hypothesis, we would argue that there is difference between population mean and the sample mean. But now we found that 1.26. So 1.26 is within here. So 1.26 is around here, right? So what we will do in the conclusion, what we already know that we failed to reject the null. So we will just perceive that. We will just say that we cannot reject the null, so there is no statistically significant difference between the population mean and the sample mean. So that will be our process of the calculation. And also, equation of the effect size D is sample mean minus population mean divided by standard deviation. So that is again 17 minus 15, which is 2 here, and the standard deviation is 5. So effective size is 0.4. So 0.4 falls in between 0.2 and 0.5. So we would say that effective size is small, which means the difference between the population mean and sample mean is indicated as small. And again, by using the number, the effective size is small, and we fail to reject the null hypothesis. So there is no difference. So that is the t-test. We call that one sample t-test. And confidence interval, we can use other number, but let me show you. Okay. So the confidence interval is calculated as sample mean plus minus. So let me show this. So what is a sample mean? Sample mean is 17, right? And we already have the number, right? Sample mean and number of cases. So n plus minus t critical. So t critical. So t critical is 2.262, right? And also the sampling error. Sampling error is so 2 SEM is the minus. SEM is, let me calculate that. So the standard sampling error is standard deviation. So let me show you how to calculate it. So sampling error is standard deviation, it's here 5, divided by SQRT, which means square root. Sample size is here 10, right? Okay, so 1.58 or something. So okay, so that is maybe we can decrease the decimal place like this. Alright, so by using the sampling error, we can calculate it. So where is the, okay, so we are using this number, m minus t critical multiplied by sampling error based on the equation. So we can find this number. Maybe we can decrease the decimal place again. And also, again, the mean plus t critical multiplied by sampling error. Okay, this number. Alright, so now we found that 13.42 through 20.58. So this is the range of the confidence interval. So we have the 95% confidence that the population mean will be between 13.42 through 20.58. So you might be very confused about this equation. So let me show you again. So you can see that. So sample mean is 17 here, right? It's correct. T critical is what we found here. So 2.262, so it's same here. And the sampling error, that is, let me show you the equation again. Sampling error is standard deviation divided by square root number of cases. So not this number. So where is the number here? Alright. So now we have standard deviation is 5 and number of cases is 10. So in this equation, 5 is divided by square root number 10. So this is SEM. So by using the calculation of the, let me see. Let me show the equation again. So T critical, okay, so confidence interval is sample mean plus minus T critical multiplied by sampling error. So that's why. Okay, the mean, so okay, let me do it. The mean minus T critical multiplied by sampling error. And then the mean plus sampling T critical multiplied by sampling error. Then those numbers are created and reduce the decimal places to make the easier or simpler number. So now we have those numbers. So this is how to calculate the confidence interval and also how to use the one sample t-test based on the flows of the hypothesis testing. Alright, so this is not the end of the lecture, but where are other things? So let me stop here and let me post on next video because I don't want to make it to be too long video here. Okay, thank you for watching and see you in next video very soon.